Let's review the components of a machine learning algorithm. Every machine learning algorithm has three components. Representation, which is how to represent knowledge, in this case, the type of algorithm. Choose a feature representation for your algorithm. Next is evaluation. What criteria to choose to evaluate the performance of your algorithm. Then the third one is optimization. Choosing the best parameters or setting for your model to have the best performance. Here is a list of topics that we will cover in this lecture. We will dig deeper and get more serious about the reality of machine learning and investigate topics like which machine learning algorithm to choose for our problem. This is an interesting and important question that doesn't have an easy answer. Next, what if our machine learning algorithm has a poor performance and disappointing performance? Well, I have to tell you in advance before you start entering the machine learning world. This is very common, and it's something that happens for every time that you try to solve a problem using a machine learning algorithm. You're going to be disappointed first by the performance of your algorithm most often than not. But later on, you're gonna build skills how to overcome these issues. But just want to let you know that this is a common issue, and you have to get your expectation lower than much lower than perfect. We will talk about overfitting and underfitting, what they mean, and how to resolve them, or try to resolve them at least. We talk about bias and variance. And we also talk about regularization. And we're going to learn about two regular regression models, the ridge regression and the lasso regression. And also we're going to learn about polynomial features and normalization. All right, let's get started. The learning process. Supervised or inductive algorithm, which is going to be most of the algorithm that we're going to learn in this course, are based on induction logic, meaning there is a general trend or pattern or rule in the population data that we can induce from, which is also called generalization, by studying the sample data. So we want to study the sample data and learn or uncover a general trend and then generalize that to the population. So you need to remind yourself or remember the concept that you learn in statistics, the sample and population. What this really means? This means we are able to develop algorithms that have the ability to generalize. By learning from the training data set, they can make accurate predictions or close to accurate predictions about unseen new data. Model's accuracy. The performance of a model on training data is not a good measure for the accuracy of an algorithm. Otherwise, we could just build a model that would memorize all the training data and would yield a 100% accuracy rate. That is why we split our data into training set and test set, so we can train on our algorithm on the training set and then get an evaluation of its accuracy based on the test set that the algorithm has not seen. However, there is a catch to this. A model that has a poor performance, even on the training data, would likely have also a poor performance on the test data. This is called underfitting. On the other hand, too much emphasis on the accuracy of a model on the training set would lead to a phenomenon as called overfitting. These two, underfitting and overfitting, are one of the two common problems or issues that we face as machine learning algorithm developers.